logging into a Linux system. In this video, we are going to see about logging into a Linux system. On a single user Linux or Mac OS X desktop or laptop computer, you can start the terminal program and be automatically signed in. There is no need for account login or password. On a remote server, you will always need to log in with at least account name and password. Login is a Unix command for logging into a Unix system. Login is a built-in command in CSH. There is also an external utility with the same name and functionality. In many modern systems, the functionality of login is hidden from the user. The login command runs automatically upon connection. In some old computers, you may need to type a special character or even type login to bring up the login program. If you log in remotely to a server, you will be prompted for your user or account name and password. If you start up a terminal emulator and shell from a graphic user interface, you will probably already be authenticated and immediately go to the shell. That is, although some of the startup activity of login will still be done for you. The activities that login perform at startup of a shell, because you need more familiarity with the shell before you can understand that material. Select system or host. If you are signing into a system that combines multiple computers, you will first need to indicate which computer you are logging into. You may already be logged in if you are using a terminal emulator on a personal computer or workstation. If so, you don't need this step. You will see a prompt indicating a choice of computer, such as, that is, only one of these will appear. If you see login instead, then you don't have to worry about choosing the system. Enter the identifying name of the computer system you are assigned to use, followed by the enter or return key. Your system administrator can provide you with this information. On some networked systems, you can abbreviate with the first 2 or 3 characters of the computer name, that is, as long as it is enough to uniquely identify which computer is intended. If you are successful, you will be presented with the login prompt. Account name. You may already be logged in if you are using a terminal emulator on a personal computer or workstation. If so, you don't need this step. Ask your system administrator for your account name. If this is your own personal system, then use the account name setup during installation. Many modern installed disks include a utility for creating a new account. At the login prompt, enter your account name, followed by the enter or return key. Type your account name in lowercase letters. Unix assumes that an account name in all capital letters indicates an old input or output device that doesn't support lowercase letters. that is, such as an old style teletype or TTY. Also, if you see uppercase letters for the login, then you cannot use lowercase letters in the password. If you enter a valid account name, you will be asked for your password. On many computers, you will be asked for a password even if you enter an incorrect account name. This is a security measure to help prevent guessing account names. Password. You may already be logged in if you are using a terminal emulator on a personal computer or workstation. If so, you don't need this step. Ask your system administrator for your password. If this is your own personal system, then use the password setup during installation. Many modern installed disks include a utility for changing the password for an existing account or for creating a new account with a new password. At the password prompt, enter your password followed by the enter or return key. In some cases, a new account doesn't have a password. Also, it is common for Mac OS X to have no password for the user account. If your account doesn't have a password, just press the enter or return key. Change your password to a secure password at your earliest opportunity. Failure will be indicated by an error message. The exact error message varies by system, but will probably be something similar to. The most likely reasons are incorrect account name, incorrect password. You type the account name in uppercase letters, that is, check the caps lock key. Linux virtual consoles. In this video, we are going to see about Linux virtual consoles. This information only applies to users of non-partitioned system P systems using a video card as their console. The Red Hat Enterprise Linux installation program offers more than the dialog boxes of the installation process. Several kinds of diagnostic messages are available to you, as well as a way to enter commands from a shell prompt. The installation program displays these messages on 5 virtual consoles, among which you can switch using a single keystroke combination. A virtual console is a shell prompt in a non-graphical environment accessed from the physical machine, not remotely. Multiple virtual consoles can be accessed simultaneously. These virtual consoles can be helpful if you encounter a problem while installing Red Hat Enterprise Linux. Messages displayed on the installation or system consoles can help pinpoint a problem. Console keystrokes and contents for a listing of the virtual consoles, keystrokes used to switch to them, and their contents. Generally, there is no reason to leave the default console, that is, virtual console, for graphical installation unless you are attempting to diagnose installation problems. Elements of the X Window system. In this video, we are going to see about elements of the X Windows system. Definition. The X Windows system, that is X11, is an open source, cross-platform, client-server computer software systems that provides a GUI in a distributed network environment. Used primarily on Unix variants, X versions are also available for other operating systems. Features of the X Windows system include network transparency, the ability to link to different networks, and customizable graphical capabilities. The X Windows system was first developed in 1984 as part of Project Athena, a collaboration between Stanford University and MIT. X.org Foundation, an open group, manages the development and standardization of the X Windows system. The X Windows system is also known simply as X, X11 or X Windows. Explains X Windows system. The client or server model in X system works in reverse to typical client or server model, where the client runs on the local machine and asks for services from the server. In X system, the server runs on the local machine and provides its display and services to the client programs. The client programs may be local or remotely exist over different networks but appear transparently. X is used in networks of interconnected mainframes, mini-computers, workstations, and X terminals. X Windows system consists of a number of interacting components, including X server. Manages the display and input hardware. It captures command-based and graphics-based inputs from input hardware and passes it to the client application that requested it. It also receives inputs from the client applications and displays the output under guidance from Windows Manager. The only component that interacts with hardware is X server. This makes it easier to recode it as per the requirements of different hardware architectures. Windows Manager. The client application that manages client Windows. It controls the general operations of the Windows system like geometry, appearance, coordinates, and graphical properties of X display. Window Manager can change the size and position of windows on the display and reshuffle windows in a window stack. X Client. An application program that communicates with X server using X protocol. Xterm, Xclock, and Xcals are examples of X clients. X manages its windows in a hierarchical structure. The shaded area that fills the entire screen is the root window. X client application windows are displayed on top of the root window and are often called the children of the root. X Windows system. In this video, we are going to see about X Windows system. The X Windows system, that is commonly referred to as X or X11, is a network transparent graphical windowing system based on a client or server model. primarily used on Unix and Unix-like systems such as Linux. Versions of X are also available for many other operating systems. Although it was developed in 1984, X is not only still viable but also is in fact the standard environment for Unix windowing systems. The X Windows system is a graphical windowing system that was developed at MIT in 1984. X was developed as part of Project Athena, a cooperative effort between MIT, IBM, and Digital Equipment Corporation to develop a network of heterogeneous engineering terminals that could be used for teaching purposes. The current version X11 was released in 1987 and is now up to X11 Release 6, known as X11 R6. One reason X has had such staying power is that from the beginning it incorporated many of the windowing capabilities that we now take for granted. These capabilities include network transparency, graphical capability, the use of a mouse, and the ability to link together a heterogeneous network of workstations from different vendors. In addition, X was intentionally designed to provide a low-level mechanism for managing the graphics display, but not to have any control over what is displayed. This means that X has never been locked into a single way of doing things. Instead, it has the flexibility to be used in many different ways. Both the simplest window manager and the most complex desktop environment can and do use the X Windows system to manage the display. The responsibility and stewardship of X is currently in the hands of the X.org Foundation. The X.org implementation of the X Windows system is included with most of the major Linux and free Unix distributions. Until 2004, the standard version of X was X-free86, developed by the X-free86 project. New licensing restrictions imposed by X-free86 led to the switch to X.org. The X client or server mode. In this video, we are going to see about the X client or server mode. The client or server model, as it's implemented by X, may seem backward at first glance. Generally, we think of servers as remote machines like file servers, news servers, or mail servers with local clients accessing the servers. For X, however, it is a server that runs on the local machine, providing its services to the display based on requests from client programs that may be running locally or remotely. The server also manages the input devices, that is usually a keyboard and mouse, and it manages the display of colors and fonts on the screen, all based on request from a client. One of the most significant features of X is that it was specifically designed to work across a network. The client and the server communicate via the X protocol, a network protocol that can run locally or across a network. Regardless of whether a client program is local or remote, it communicates with the server through the X protocol. Working with X. In this video, we are going to see about working with X. When you run the X Windows system, the server manages the display based on requests from the window manager. The window manager is an application that is itself an X client with responsibility for managing the appearance and placement of the windows on the screen. X itself has no role in determining the appearance of the screen or what users are allowed to do with Windows. That is the job of the window manager. For example, some window managers allow you to double-click in a Windows title bar and roll up the window into the title bar like rolling up a window shade. That is, this is referred to as shading. Other window managers don't have that feature. X doesn't care. It's a window manager concern. The X server's job is to provide the low-level support so the window manager and other applications can shade or not as they choose. Similarly, the window manager takes care of the appearance and placement of the windows. It doesn't determine what goes on inside. The window might be a terminal window that is called an Xterm, where the user runs standard Unix commands, or it might be running an X client application like the Xcalc calculator, a web browser, or an Emacs session. It's the client application running in the window that determines what happens inside its windows. Most people today run one of the desktop environments, KDE or GNOME. The desktops go further than a window manager in providing an integrated graphical environment where all applications and windows have a common look and feel. The desktop environments also include session management for saving and restoring your work sessions. But if you look underneath, you will still find the X Windows system managing the display, and you will find a window manager sitting between X and the desktop. X is hidden 2 levels down from the desktop. For that reason, if you want to explore X further, it's helpful to run with just a window manager for a while, even if you end up going back to the desktop. Running the X Windows system. In this video, we are going to see about running the X Windows system. You can run the X server in 2 ways, with the X Display Manager, that is XDM, or by booting on the command line and starting X manually. There are too many distributions, each with its own configuration and startup procedures, for me to be able to provide general instructions for running the server in this article. But as an example, here's a quick way to set up a Fedora core Linux system to boot to the command line so you can run the X server manually. This should work for other Red Hat based distributions, and something similar should work for other distributions. Your first step while you are still in the desktop is to use your favorite text editor to create a startup script in your home directory. If there isn't already such a script, in this case, since we are going to start manually, the file should be named .xinitrc. If we are going to use XDM, it would be .xsession. Be sure to make the file executable. The last line of the file should run the window manager. In fact, that can be the only entry in the file. But it's useful if you want to do work, to set up at least a couple of Xterm windows and maybe start a browser or any other application program that you use regularly. For example, is my Xinitrc file. This file starts up two Xterm windows with sidebars and the specified geometry. 80 x 55 is the size of the window, that is 80 characters wide and 55 lines long, and +5 indicates where on the screen the upper left corner should be placed. Every line except the last one ends with an and to put them in the background so the next line can be executed. After starting up a clock with an ivory background, that is the face, and a blue foreground, that is hands, the screensaver program, the script runs the window manager FVWM. Now we are ready to establish that we don't want to boot into X. As root, edit the file /etc/initab and update the line that sets up the initial run level. We want it to start in run level 3, that is multi-user mode, instead of run level 5, that is X11 mode. Then, when you restart the system, it will boot to a regular terminal window instead of X11, displaying a login prompt. After you log in, you can start X. As long as a startup script is running, the X server will also continue running. Since the last command in the script starts the window manager, X will continue to execute until the window manager is terminated, which terminates the script. Thus, in effect, stopping execution of the window manager also stops the X server. In FVWM, to stop the window manager, select Exit FVWN from the root menu, the menu you get when you click on the root window, that is the background behind the other windows. It shows an example of an FVWM root menu. Exit FVWM is the last entry. When you click on it, a sub-menu asks whether you really want to quit FVWN, whether you want to restart FVWN, or whether you want to start a different window manager. It shows my screen running FVWM based on the Xinitrc file we just saw, after I had been working for a while, running commands in the Xterm windows and starting some additional X clients. The X server. In this video, we are going to see about the X server. The X server manages the display hardware. The server captures input events from the user via keyboard or mouse, that is, or other input device, and passes the information to a client application that has requested it. It also receives requests from the application to perform some graphical action. For example, if you use your mouse to move a window on the screen, the X server passes the information to the window manager, which responds by telling the server where to reposition the window, and the X server performs the action. If the client is a calculator, such as Xcalc, it might request that digits be displayed into the window as the user clicks on buttons to enter a number. In any case, it is always a server that interacts with the hardware. Thus, only the server software has to be hardware specific. In fact, only the parts of the server that actually interact with the hardware need to be rewritten for X to be ported to new systems or to be usable with a new terminal or a new type of input device. For example, as long as the X clients are written to use X protocol, they can run on any system and communicate with the X server. Changing your password. In this video, we are going to see about changing your password. To set or change a password, the password command is used. The command syntax looks like this. To change your password, just enter the password command. You will be prompted for your old password and your new password. The password command will try to enforce use of strong passwords. This means it will refuse to accept passwords that are too short, are too similar to prevent passwords, are dictionary words, or are too easily guessed. If you have super user privileges, you can specify a username as an argument to the password command to set the password for another user. Other options are available to the super user to allow account locking, password expiration, and so on. The root user. In this video, we are going to see about the root user. On every Linux system, the root account is a special user that has administrative rights. Logging in as root or executing commands with root privileges is necessary for many tasks. If you need to perform tasks as the root user, make sure that you fully understand the commands you're running and what consequences they have. A single careless or malformed command run as root can make the entire operating system unusable. Do your research and always double check every command before pressing enter. Logging in as root. The root account is similar to any other account in that it has a username that is root and a password. If you know root's password, you can use it to log in to the root account from the command line. There is a special command named su for super user or switch user that allows you to switch over to the root account. From the command line, enter the password once prompted for the password. If successful, you are switched to the root user and can run commands with full system privileges. Be careful while logged in as root. It is easy to forget that you are currently the root user, and you might inadvertently run a command thinking you are only a mere mortal. One way to remind yourself if you are root or not is to check your command prompt. Many systems end their command prompt with a $sign if you are logged in as a normal user, but with a £sign if you are root. Or you can use the who AMI command to determine the account you are using. When finished with your administrative task, you can run the exit or logout command to return to your standard user account. When logging in as root, it is often useful to use a single dash after the su command, like this. This command simulates a complete root login. It executes all of the root user's shell initialization scripts and sets all environment variables as if the root user were logged into a fresh shell session. Depending on what task you need to perform and how the root account is configured, this form of the su command might be optimal for you. Running commands as root without the root password. It is possible and often preferable to run commands as root without logging into the root account by using the sudo command, which stands for super user 2. If you prefix a command with sudo, you are prompted for your password, that is, not the root password, and your name is checked against a special file called sudos. If your account is listed there, your command will be run with root privileges. Using sudo makes it much more difficult to forget that you are root, since you are not logged in into the root account and are never going to forget to log out. Also, typing sudo every time you run a potentially destructive command reminds you to be extra careful and double-check yourself. If you need to add a user to the sudos list, you should use the vsudo command that requires root privileges to run and allow you to safely edit the sensitive sudos file. LinuxChange your own password. Log in using the SSH client or open a command line terminal, that is, select Applications, Accessories, Terminal, then type the following command. First, the user is prompted for their current password. If the current password is correctly typed, a new password is requested. The new password must be entered twice to avoid typing errors. Running password command with no arguments will allow you to change your own password. LinuxChange root's user password. To change root's password, you must first log in as root user or use sudo or su command to obtain root's credentials. To become the root user, enter. To change root's password, enter. LinuxChange another user's password. To change the password of another user, log in as root and note about protecting your password. Your password unlocks your account and all data on Linux, so you need to protect your password. Here are some simple tips. Please do not write down your password, you need to memorize it. Do not use the same password for all your accounts including SSH, GIT, file, and email servers. Use unrelated passwords for systems controlled by different organizations. Do not share or give your password, in particular to someone claiming to be from computer IT support department or a vendor. Make sure no one watch you enter your password. Change password periodically. Choose a hard-to-guess password. Avoid using the following passwords. Simple words or words that you'd find in a dictionary. Do not use your name including that of a spouse, child, pet, city, and so on. Do not use your birth date, SSN or PAN, phone or mobile number and driving license numbers. A good password consists of mixture of upper and lower case letters as well as digits or punctuation. At least 8 characters long. Changing identities. In this video, we are going to see about changing identities. At various times, we may find it necessary to take on the identity of another user. Often, we want to gain super user privileges to carry out some administrative task, but it is also possible to become another regular user to perform such tasks as testing an account. There are 3 ways to take on an alternative identity. Log out and log back in as the alternate user. Use the su command. Use the sudo command. The su command allows you to assume the identity of another user and either start a new shell session with that user's ID or issue a single command as that user. The sudo command allows an administrator to set up a configuration file called /etc/sudos and define specific commands that particular users are permitted to execute under an assumed identity. The choice of which command to use is largely determined by which Linux distribution you use. Your distribution probably includes both commands, but its configuration will favor either one to the other. We will start with su. Su run a shell with substitute user and group IDs. The su command is used to start as another user. The command syntax looks like this. If the one option is included, the resulting shell session is a login shell for the specified user. This means that the user's environment is loaded and the working directory is changed to the user's home directory. If the user is not specified, the superuser is assumed. Notice that strangely, the one may be abbreviated as, which is how it is most often used. To start a shell for the superuser, we would do this. After entering the command, we are prompted for the superuser's password. If it is successfully entered, a new shell prompt appears indicating that this shell has superuser privileges, that is, the trailing hash rather than a dollar symbol, and that the current working directory is now the home directory for the superuser, that is normally /root. Once in the new shell, we can carry out commands as the superuser. When finished, enter exit to return to the previous shell. It is also possible to execute a single command rather than starting a new interactive command by using su this way. Using this form, a single command line is passed to the new shell for execution. It is important to enclose the command in quotes, as we do not want expansion to occur in our shell but rather in the new shell. Editing text files. In this video, we are going to see about editing text files. GUI text editors. Text editing applications for the Linux windowing system X Windows, more commonly known as X11 or X. If you are coming from Microsoft Windows, you are no doubt familiar with the classic Windows text editor, Notepad. Linux offers many similar programs including NEdit, gedit, and gene. Each of these programs are free software and they each provide roughly the same functionality. It's up to you to decide which one feels best and has the best interface for you. All three of these programs support syntax highlighting, which comes in handy if you are using them to edit source code or documents written in a markup language such as HTML or CSS. NEdit. NEdit, which is short for the Nirvana editor, is a straightforward text editor that is very similar to Notepad. It uses a motif-style interface. If you are on a Debian or Ubuntu system, you can install NEdit with the following command. GENE. GENE is a text editor that is a lot like Notepad++ for Windows. It provides a tabbed interface for working with multiple open files at once and has nifty features like displaying line numbers in the margin. It uses the GTK Plus interface toolkit. On Debian and Ubuntu systems, you can install GENE by running the command. gedit. Gedit is the default text editor of the GNOME desktop environment. It is a great text editor that can be used on just about any Linux system. On Debian and Ubuntu systems, gedit can be installed by running the following command. Terminal-based text editors. If you're working from the Linux command line interface and you need a text editor, you have many options. Here are some of the most popular. Pico. Pico started out as the editor built into the text-based email program Pine, and it was eventually packaged as a stand-alone program for editing text files. Pico is a scientific prefix for very small things. The modern version of Pine is called Alpine, but Pico is still called Pico. You can find more information about how to use it on our Pico command information page. On Debian and Ubuntu Linux systems, you can install Pico using the command nano. Nano is the GNU version of Pico and is essentially the smaller program under a different name. On Debian and Ubuntu Linux systems, Nano can be installed with the command vim. When at the Linux command line, you sometimes want to create or make changes to a text file without actually running a text editor. Here are some commands that you might find useful. vim, which stands for VI Improved, is a text editor used by millions of computing professionals all over the world. Its controls are a little confusing at first, but once you get the hang of them, Vim makes executing complex editing tasks fast and easy. For more information, see our in-depth Vim guide. On Debian and Ubuntu Linux systems, Vim can be installed using the command Emacs. Emac is a complex, highly customizable text editor with a built-in interpreter from the Lisp programming language. It is used religiously by some computer programmers, especially those who write computer programs in Lisp dialects such as Scheme. On Debian and Ubuntu Linux systems, Emacs can be installed using the command redirecting command output in a text file. When at the Linux command line, you sometimes want to create or make changes to a text file without actually running a text editor. Here are some commands that you might find useful. Create an empty file. It's common to use the command touch. Touch updates the A-time and M-time attributes of a file as if the contents of the file had been changed without actually changing anything. If you touch a file that doesn't exist, the system will create the file without putting any data inside. .g, an empty file with the touch command. For instance, the command will create a new empty file called mylife.txt. If that file does not already exist, redirecting text into a file. Sometimes you need to stick the output of a command into a file. To accomplish this quickly and easily, you can use the right arrow symbol to redirect the output to a file. For instance, the echo command is used to echo text as output. By default, this goes to the standard output, the screen. So, the command will print that text on your screen and return you to the command prompt. However, you can use right arrow to redirect this output to a file. For instance, we'll put the text, "This is my text," into the file myfile.txt. If myfile.txt does not exist, it will be created. If it already exists, its contents will be overwritten, destroying the previous contents and replacing them. Here's an example using another command. The above command executes the ls command with the I option, creating a detailed listing of files in the current directory, and output the listing to the file directory.txt instead of printing it to the screen. If directory.txt does not exist, it will be created first. If it already exists, its contents will be replaced. Redirecting to the end of a file.